In this video, we're looking at block design, how an analog layout can be converted to a digital, and how to set things up in the software.
Hello and welcome to this video tutorial in which we will talk about trackwork design. We're continuing on this theme since the two previous videos. In this video we'll talk about a block design, block sections, which has been around since, I don't know, maybe 50s or 60s, something like that. At that time all the layouts were analog, so the block sections then were like isolated pieces of track which was powered from one transformer. So you could control the train movement in that section with the knob of your transformer, more or less. And in the beginning and in the end of each track section there were a signal. And the signal had an isolated track section. So when the train arrived to that, in the end of the block to that signal track, and the signal was red, stop, then it was powerless, so the train will stop. And when the signal goes green, then power goes on and the train continues to the next section. So that is the basic thought of having blocks. So the idea here is to have one more block at least, then you have trains moving, because otherwise there will be no movement, of course. And while going to digital, this kind of pattern continued, but instead of this isolated track section, because the digital system are all powered at all time, it is controlled by sending a stop signal to the locomotive address, which is traveling through that block section. And instead of the isolated track section, you have sensors. So when the train passes over that signal section, there is a signal sent back to the system saying, hey, here I am. So that is basically the difference. But we're going to have a look at how to set this up and how to convert an analog system to a digital, which is quite easy, but you have to know how.
Alright, so here's the typical setups for an analog system. You see the direction of travel for the trains. It first arrives to is a stop track, which is an isolated track section connected to the signal. Then the train passes over sensor 1, which turns that signal to red and isolates that stop track, so any train following will stop on that track. Ultimately, the train will arrive to the end of the block and sensor 2, and that will give a clear signal to the signal, and it will power up the stop track. Now, when two blocks follow after each other, which they typically do on the layout, the only difference is that you move in the sensor 2 from the first signal behind the first sensor for the second signal. This will assure that the first block is not ready for new trains until the first train is fully into block 2. Otherwise, everything's the same. So if we now want to convert this to a digital system, then we have plenty of isolated tracks with a separate feed to choose from when choosing sensors. And I typically do like this. The first sensor is the red, old red analog, and the second one is the stop track. Now, in the digital system, you don't have to switch positions of the sensors to assure that the train is fully into block 2 before the block 1 gets released for new trains. And that is because this is solved in the software. So if you're instead building a new system, well, then your layout for blocks will look like this instead. So when the train passes sensor 1, it will send a command to the computer telling that the train has entered block 1. And then ultimately when it reached the last sensor in that block, it will signal in. So now the train is fully in. And after that, it will continue to the next block and do the same thing there. And when our train has reached the in sensor in block 2, well, then block 1 will be available for new trains. A rule of thumb for determining the length of a block is that it should be longer than the longest train you expect along that line. So for the main line, the full length, branch line, maybe shorter, in an engine depot, well, at least as long as the longest locomotive. So here is one of my sidings. This one will have 2 sensors as said. So this will be the location for the first sensor, which will be the enter sensor coming from this direction. Over here I will have the in sensor, which tells the system that the train is now fully in this block. To cut the rails I use the thinnest saw blade I have and I insert it into my motor grinder. Then I make first a 1 cut and then about 4 inches away I make another cut through the rail. So now I've electrically isolated a section of the track. I use the same process to make the other sensor. Then to secure this slot and the isolation, I insert a drop of glue, of Patex glue, into that slot the saw blade created. That will prevent the rail from moving with the train. Then it's just to solder a piece of wire to the rail, which is in turn connected to the feedback decoder. Now, working with sectional tracks is basically the same thing. However, if you have a 3-rail system like this Marklin K track, there is a bridge over between the rails here, and this one needs to be cut. Otherwise, there's no way to sense that we have a train movement on this track piece. So I'm cutting this here, and then just to be sure, I fold it away using a screwdriver. So I push it like this. And then of course we need to do the same thing with the other side, which has exactly the same setup with a crossover between the rails. Now, if you're using a 2-rail system like Trix, they also have this C-track, but without the center rail. They of course do not have these crossovers between the rails, because that would of course cause short circuits. But for the 3-rail system, this operation is necessary. Otherwise, it's pretty much the same. You solder a cable to that contact blade, and then you buy these isolators and stick them over the contact blade in each end of this track, and voila, you have isolated that rail section you just soldered a cable to. So now when an engine, locomotive or a car rolls on this track, it will short circuits between the 2 rails, send a signal to the feedback decoder, and we know that something's there. So here are the isolator now assembled, as well as the cable. So let's insert this now into our piece of layout. And as you see here, I've marked the position of the sensor tracks with an orange tape together with the address for it. So I have inserted an isolator here in this turnout, and now let's assemble this track piece here, which holds our sensor. And with that done, we can now connect it to the feedback decoder, depending on what type of feedback. I'm using the S88 from Marklin here. Now, to check that this sensor works, you need to add in the CS2 a whole track plan with all different sensors and assign them to different addresses. On the CS3 you have the sensors here. This should be sensor number 24, and as you see, the sensor K24 lights up. So this one's working properly, and if we let it roll off, well, then it goes out. So, perfect. Now, this is of no use unless we have a traffic planning software like Rockrail here, or Train Controller, or iTrain, or whatever you select. I've added the blocks with sensors. Block 1, Skogen SP1 with 2 sensors, and the other one, Linje B-bana 3 with 2 sensors. So here's our sensor 24. I'm going to show you now how things work once you have a locomotive set up. So I drag that locomotive to the first block. I switch on the track power and enable auto mode, which means automatic mode. So let's now drag and drop with the mouse that locomotive from one block to the other. It will run first over that sensor, you see how it lights up, and then it enters this block, and ultimately it will reach the in sensor, our new sensor number 24. Yeah.
All right, so now we're geared for automatic train traffic. Depending on what level you want to take it to, if you want to install rock rail or train controller or something like that, iTrain, then this is all you need to have really. Then it's just to set up the feedback decoders and everything, and you're ready to go. But the block design is the fundamental component you need to think about when making your track work design, because if you haven't thought about that ahead, then it's more tricky to implement afterward. So, thank you very much for watching this tutorial. I hope you have used for the information provided here. If you watch the channel regularly and have use for the information, why not support the channel? Just $1-2 per month. Get over to Patreon, set up a support account there, or make a one-off donation using the PayPal dialog found in the video description below. And if you're not yet a subscriber, subscribe to the channel and enable that little bell next to the subscription button, and you will get a notification once next video gets published. Until that happens, see you.